Envision a gigantic get-together played by a ceaseless number of stars, planets, and moons, all playing together eminently. Regardless, there is one unequivocal section of this symphony that has shocked space experts for a truly drawn-out time frame. Exoplanets are normal planets that exist outside our planetary system, stowed away somewhere down in the Milky Way. You may be dumbfounded to find that among the epic number of infinite objects, there are exoplanets so like Earth, so tantalizingly equivalent yet confusing, that they may be our planet's superb twin. We hop into the fascinating area of Proxima b, found 4.2 light-years away. The James Webb Space Telescope is upsetting our journey for an understanding of these heavenly mysteries. Imagine a moment when your mind ventures across the tremendous cosmic region of our world, the Milky Way, which is home to more than a quadrillion exoplanets. That is a number with 15 zeros. To put this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon, we would have, with the end result of making one more land achievement on Earth, a Grand Canyon 2.0, that would stretch out for an enormous distance. It's generally astounding that around 20% of these great bodies have been designated Earth-like in terms of geology and atmosphere structure. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Close by these planets, there could be another quadrillion moons. Rough satellites like our moon caught in gravitational dance with their parent planets. If you somehow manage to ponder finding another body in space that harbors life or could do so, the universe offers a surge of chances. Since we have fanned out the material of praiseworthy scale, now is the time to present the expert, talented specialist, ready to paint its intricate subtleties, the James Webb Space Telescope. This wonderful Sherlock Holmes, with its enhanced focal point of convergence displaced by adaptable focal centers, beats even the most advanced optical instruments. We're not discussing any focal point. It's 6.5 meters in fundamental mirrors, 2.7 times more prominent than Hubble's. Imagine the best detail it can isolate, even in the smallest flicker of a star billions of light-years away, and then, at that, observe the subtleties of rotating planets. What makes the James Webb Space Telescope revolutionary isn't just its seeing power, but also its high-level technology, including advanced sensors and spectrographs. These gadgets can do much more than simply observe. They can explore and analyze the unique light, check the fragrance or reflection by great objects, and unravel their cools, concordance, density, and shockingly mass. As a space analyst, they can conclude whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope can respond to these questions, raising it from a simple spectator to a consistent virtuoso. It's not just a development over its progenitor, Hubble, it's more like a quantum leap. If Hubble's exposures confused you, prepare for a certifiable event of brilliant revelations. Similarly, as we expanded our look across the convoluted scene of the universe, it's worth focusing on one specific star in the heavenly show, Proxima b. Since its discovery in 2016, this bewildering planet has stood out as a Shakespearean legend, stacked up with diverse plans and issues, dazzling stargazers and anthropologists alike. So, what's going on with all the fervor? As a matter of some importance, Proxima b is essentially in our cosmic neighborhood, 4.2 light-years from Earth. To put it in context, if you could beat the general speed limit and go at the speed of light, you would arrive in just over 4 years, about the same amount of time it takes for your favorite program to fall into reruns. But let's jump further into why this closeness is so important. We're analyzing a universe that stretches over 93 billion light-years from one end to the next. So finding a planet so close and, therefore, elevating for legitimate investigation is like finding a diamond in a pile the size of Mount Everest. A pearl that potentially holds secrets about existence itself in the grand weaving of the universe. Proxima b is a complicated line offering us huge snippets of data that could reconsider how we grasp viability in life beyond Earth. It's not just Proxima's closeness to Earth that excites laid-back trained professionals, but also the spellbinding signs that this planet isn't Earth-like, but possibly Earth 2.0. Proxima b sits calmly in what space experts call the habitable zone of its parent star, where conditions are neither too warm nor too cold, but just right for liquid water to exist. Imagine fountains, wandering streams, enormous lakes, and maybe seas as deep and perplexing as the Mariana Trench. However, before we start dreaming about going to Proxima b, we should consider a few of its qualities. A single day on this charming exoplanet lasts a fluctuating 11 days. Imagine dawns that present another day as well as spread out leisurely, giving way to evening and nightfalls that stand by, creating brilliant hours that photographers long for. While it sounds pure, it also has massive implications for its environment and viability. How might human biorhythms change according to the patterns of light and dark on Proxima b? Would we truly need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way on this extremely astounding world? The central aspects of life as we know them would be both tantalizingly similar and frustratingly unconventional. It's like nature is giving us an enigma enclosed by a puzzle, testing how we might interpret what makes a planet livable. You might consider how we can gather exact and strong data about a world we've never visited. The James Webb Space Telescope delivers all of its abilities like a monster Swiss Army knife. It's more than just a telescope, it's a staggering research lab in the vacuum of space. Thanks to its creative technology, cosmologists can observe planets as well as analyze them through a crystal of scientific instruments that would make CSI labs look basic. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these faraway planets. Every element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining air pressure, density, and even the possible presence of compounds key for life, like water, organic carbon molecules, and even oxygen. Astrophysics isn't just cosmology, it's space criminal science. We don't stand around passively waiting for clues to come to us. We actively search for them, investigating the particles and atoms that make up these confounding worlds. The Webb telescope isn't just an eye overhead. It's a highly specialized research lab, expert and immense examiner all in one. It allows us to transform our speculation and hypotheses about alien worlds into strategies to verify or refute them, changing our understanding of what could exist beyond our blue dot. Just when you thought you had uncovered the most shocking layers of this cosmic onion, the direction, much like in any sci-fi thriller. Scientists using the James Webb Space Telescope discovered something astonishing from Proxima b, a signal so surprising that it spread throughout the academic corridors. The discovery of this astonishing signal sent shockwaves through the scientific community, sparking a wave of excitement and curiosity. Researchers began to wonder whether the signal was a sign of something extraordinary, something beyond what they could have ever imagined. Could it be a clue that Proxima b harbors life, or at least the potential for life? The implications were huge. The possibility that we might not be alone in the universe, that another planet so close to us could be home to life, was a groundbreaking thought. As scientists analyzed the data further, they found that the signal didn't quite match anything they had ever encountered before. The unusual nature of the signal sparked various theories. Some speculated that it could be a form of natural phenomenon, a cosmic event that occurred far beyond our understanding. Others suggested that it could be a sign of intelligent activity, a message sent across the stars. The search for answers intensified. With the power of the James Webb Space Telescope, researchers could now study the light emitted by Proxima b with incredible precision, peering into its atmosphere to analyze the chemical signatures present. Could there be evidence of technology, or even biosignatures that point to life forms? The telescope's ability to detect faint traces of elements like oxygen, methane, and carbon dioxide gave scientists the tools they needed to explore these possibilities in greater detail. This new era of space exploration brought a sense of hope and wonder to the world. The idea that we could one day visit or even communicate with an extraterrestrial civilization seemed closer than ever before. And yet, the mystery of Proxima b continued to elude even the most advanced scientific minds. What lay in the depths of that signal? What secrets did Proxima b hold? With each new observation and every breakthrough, the team behind the James Webb Space Telescope grew more determined. They knew that the answers were within reach, but they also understood the vastness of the universe and the complexity of their task. The journey to uncover the truth about Proxima b, and perhaps the broader question of life beyond Earth, would be a long one. But they were ready to press forward, driven by the curiosity and the hope that one day, they would unlock the mysteries of the cosmos. The story of Proxima b and the signal it emitted may have only just begun. In the years to come, the James Webb Space Telescope, alongside other advanced space missions, will continue to explore this fascinating exoplanet, gathering more data, testing new theories, and pushing the boundaries of human knowledge. As we look to the stars, we may find that the universe is far more mysterious, complex, and awe-inspiring than we ever imagined. And perhaps, just perhaps, we will find that we are not alone in the vastness of space. Virtual entertainment, named as a potential technosignature, was an electromagnetic discharge so puzzling and complicatedly planned that it could highlight the presence of a high-level progress. The aggregate heartbeat of mankind appeared to stop at the zenith of a discovery that promised to reshape our viewpoint on reality. Could the transmission be the verifiable affirmation that we are not alone in the universe? And similarly, as fast as it seemed, the transmission vanished without continuing, abandoning a stunning quiet as well as a labyrinth of unanswered inquiries and frothing hypotheses. Was it essentially a transient heavenly oddity, a serendipitous occasion of enormous game plan, or something different, conscious, a coded message, or even an indication of extraterrestrial insight? The singular mission cast a sad remnant of mystery over Proxima b, lighting wild discussion and hypothesis. Was it simply a passing oddity, or is it part of a much bigger story, more perplexing than we can imagine? Yet stand by, the record of our stupendous examination is incomplete. The ink has not yet dried and new sections are still being written. This time, normal specialists as well as Harvard researchers are driving a significant impact in context. As we continue our quest for extraterrestrial life, they are not content with investigating the transmissions and peculiarities we've discussed up to this point. They are raising the stakes by transforming the James Webb Space Telescope into a kind of monster night vision telescope. They expect to look for artificial light sources in both the dull and illuminated areas of far-off universes. We're taking a gander at amazing possibilities such as the chance of recognizing fake versions of cities shining in the dark like brilliant SPS. Imagine seeing the glowing light emissions. It could be a city murmuring with the presence of a high-level human civilization, radiating its gleam into the monstrous, tremendous seas. As we continue to unravel the mysteries of the universe, the endeavor for extraterrestrial life takes on new perspectives beyond the prompt interest in Proxima b. Our phenomenal chase digs further into the vast new regions of space. This pursuit is driven by both mechanical advancements and a significant interest in our place in the universe. Persistent jumps forward in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biomarks, and ground-based observatories have extended our capacity to identify, distinguish, and study these far-off universes. One particularly charming area of study is the quest for biomarks, indications of something going on under the surface. These signs could include air gases like methane or carbon dioxide, which, under the right conditions, could suggest natural cycles. The JWST's abilities stretch beyond basic detection. Its advanced instruments can measure the atmospheric composition of exoplanets with shocking precision. By focusing on starlight that filters through an exoplanet's atmosphere, researchers can identify chemical markers indicative of life. For instance, the presence of water vapor alongside other key molecules, such as oxygen or ozone, could highlight the potential for life-supporting circumstances. Another road of exploration involves concentrating on the conditions of these far-off universes' environmental models. In light of data from the JWST, scientists can assist in predicting whether an exoplanet's conditions could support liquid water. This is crucial as water is considered a vital component for life as we know it. Researchers are particularly intrigued by planets situated in the habitable zone of their parent stars, where temperatures could permit stable liquid water. The hunt also extends to the moons of exoplanets. Some of these moons, especially those in the habitable zones of their host planets, could have conditions conducive to life. For instance, icy moons in our own solar system like Europa and Enceladus are thought to harbor subsurface oceans beneath their frozen shells. Similarly, moons orbiting exoplanets could present environments where life could exist. Furthermore, the concept of technosignatures has gained some momentum. These indicate advanced human civilizations that may be perceptible through artificial structures or innovations. This could include superstructures like Dyson spheres, hypothetical constructs designed to capture a star's energy, or strange patterns in radio transmissions. As we refine our global collaborations and observational strategies, the search for technosignatures could uncover the presence of extraterrestrial intelligence. In addition to technological advances, global collaboration plays a crucial role in the search for extraterrestrial life. Partnerships between space agencies, research institutions, and private businesses enhance our ability to explore space. Model missions to Mars and other celestial bodies include contributions from various nations, pooling resources and expertise to achieve shared goals. Public engagement and education are also essential parts of this mission. The excitement surrounding space exploration drives the next generation of scientists and engineers. Effort programs and educational initiatives help foster an interest in STEM fields and encourage young people to pursue careers in space science. The development of new technologies also contributes to our understanding of the universe. Advances in telescope design, data processing, and computational models improve our ability to detect and study distant exoplanets. For example, cutting-edge space telescopes like the planned Very Large Telescope (ELT) and the Habitable Exoplanet Observatory (HABEX) are set to provide even more detailed views and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, each new discovery raises new questions and areas for investigation. The search for extraterrestrial life is not just about finding alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our knowledge and expands how we could interpret being human. The study of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With every advancement, we edge closer to answering some of the most important questions humanity has ever posed. As we continue to explore the universe, the opportunities for discovering new forms of life and understanding our place in the cosmos remain boundless. As we continue our quest to understand the cosmos, the search for extraterrestrial life remains one of humanity's most profound endeavors. With each step forward, we unlock new layers of mystery, revealing the vastness of the universe and our potential place within it. These explorations not only aim to find life elsewhere but also help us understand our origins and the nature of life itself. As technology advances, our tools and methods become increasingly sophisticated, offering us glimpses into worlds that were once beyond our imagination. The discovery of exoplanets, planets outside our solar system, has opened up a new chapter in our understanding of the universe. Scientists are now able to study these distant worlds with unprecedented detail, examining their atmospheres, climates, and potential for habitability. The James Webb Space Telescope, with its advanced capabilities, has become a key player in this search, providing detailed observations of exoplanetary systems and the conditions that might allow life to thrive. The possibility of finding life, whether microbial or intelligent, is no longer confined to the realm of science fiction. As we push forward with more ambitious missions and technological breakthroughs, the question of whether we are truly alone in the universe grows ever more urgent. For some, the search for extraterrestrial intelligence, SETI, is not just about finding alien civilizations but also about challenging the very nature of our existence. The discoveries we make in this search could reshape our understanding of life, intelligence, and the future of humanity itself. While the search for alien life is a central focus, it is also part of a broader scientific effort to understand the origins of life. How did life emerge on Earth, and could similar processes have occurred elsewhere? Are we looking for life that is similar to ours, or are we prepared to recognize and understand radically different forms of life that may not follow the same biological principles? The study of exoplanets and the search for biosignatures have shifted the focus of astrobiology from Earth-centric views to a more universal perspective. As we continue to explore these far-off worlds, we are not only looking for life but also gaining a better understanding of the processes that govern the formation of habitable environments. The study of alien worlds provides insights into the future of our own planet, helping us understand the delicate balance required to sustain life and the potential consequences of disrupting that balance. In this pursuit, humanity is united by a common goal: to answer one of the most fundamental questions of all: are we alone in the universe? The pursuit of this knowledge drives technological advancements, fosters international collaboration, and inspires future generations of explorers. Each discovery brings us one step closer to understanding not only the universe around us but also our place within it. As we look ahead, the search for extraterrestrial life will continue to shape the future of science, philosophy, and exploration. New technologies such as next-generation space telescopes will open new frontiers, allowing us to study even more distant exoplanets with greater precision. Upcoming missions to the Moon, Mars, and beyond will help prepare us for the day when humanity may extend its reach into the cosmos. In the end, the search for life beyond Earth is more than just a scientific quest. It is a journey that challenges our beliefs, fuels our imagination, and connects us all in the shared pursuit of knowledge. Whether we discover that we are not alone or realize that Earth is the only cradle of life, the journey itself will forever transform our understanding of the universe and our place within it. The infinite possibilities that lie ahead will continue to inspire and challenge us as we venture into the unknown, ever closer to answering one of humanity's most profound questions: are we truly alone in the universe?